Hello. So today we are doing prime factorization. So our lesson objective, we're going to factor composite numbers into their prime numbers using exponents to generate equivalent expressions. There's a lot of vocabulary, so we're going to discuss vocabulary and evaluate equivalent expressions using prime factorization. And the big thing is you want to be able to answer how can prime factorization be used to generate equivalent expressions. Okay, so this first one is just a warm-up from before break, and it just says, please write an expanded form. So if you remember, the expanded form just means, can we please just take it and multiply it out? So if you remember, the 8 is the base, and the 3 is the exponent. So the 3 tells me how many 8s I'm multiplying together. So then we would have 8 times 8, which is 64. And so then 64 times 8. 8 times 4 is 32. 8 times 6 is 48 plus 3. 48 plus 3 is 51. So the expanded form, that was the standard form. This is the exponential form, the one that I circled. Then this expanded form, and then the standard form would just be 512. Okay, so some vocabulary. This is a review. Your prime numbers are those numbers that only have two factors. So a factor is just numbers that we can multiply together. Let's see if I can actually spell this in this tiny little spot. Multiply. Together to get other numbers, period. And then, so these are the ones that, these are the prime numbers that I really want you to kind of focus on. And the process of factoring a number into only prime factors. That's what prime factorization means. It actually says it in the word. It's for the prime factors is what we're looking for. Okay, so how to do this? How in the world do we do prime factorization? Well, so we still have the standard form, the expanded form, the exponential form that we talked about when we did exponents, okay? But this time, instead, they're gonna only give you the standard form, and you need to break it down into expanded form and exponential form, okay? So if I give you something like 16, we're gonna create something called a factor tree. Okay, so we're going to pick two things that multiply to get 16. So in this case, we did 2 times 8. And whenever you get to your prime numbers, anytime you get to a prime factor, you're going to circle it. Okay, because it's done. The only thing you can do is 1 times 2, and that doesn't do anything. Okay, so then we're going to break down 8 because 8 is not prime. So we break it down 2 times 4, and then we circle that 2 because it's prime. And then we need to break down the 4 because it's composite. It can keep going. Okay, so when we look at 16, when we're looking at the expanded form, it's all of those prime numbers we circled, all those prime factors. So 2 times 2 times 2 times 2. When we have repeated multiplication like this, we know that that means that we have an exponent. So we know there's 1, 2, 3, 4 of them. So my exponent is 4 and my base is 2. Now you might be saying, well, I wouldn't have started with 2 and 8. I would have started with 4 and 4. And that is perfectly fine. That's the best part about this is that you can start with any multiplication facts as long as it does actually multiply to that number. So in this case, we did 4 times 4. And if you notice, it actually kind of looks like it's a little bit less work. This is because the bigger the factors you use, the less times you're going to have to do that. Now you might be going, okay, well, how do I know what I can divide by? What if I get a weird number that I don't know what to divide by? These are kind of 4 rules we like to live by in math. The divisibility rules. So how do you divide? How do you know that something can divide by 2? Well, we've talked about this. It means it's an even number. So if it ends in 0, 2, 4, 6, or 8, we know it can divide by 2. Let me do the ones that you know. If you can divide by 5, if the number ends in a 5 or a 0, And then obviously if it ends in a 0, then we know it can divide by 10. But this is the fun rule. This one right here is like it's just a fun rule to know. If you want to know if something can divide by 3, so maybe it can't divide by 2, 5, or 10, and you're like, what do I divide by? So you could try 3. So if the digits add up to something that can divide by 3, then that means it is divisible by 3. So take 27. If we add the digits 2 plus 7, we get 9. Well, I know I can count to 9 by 3s, which means that 27 can divide by 3. It's just a fun little divisibility rule. Okay, so then I have 20. So 20, you could start with 4 or 5, 4 times 5. You could start with 2 times 10. I'm going to start with 4 times 5. And you should be asking yourself, do I have any of my prime numbers here? And the answer is yes. So I circle it. 4 is not prime because I can do 2 times 2. So then I'm going to write it in the expanded form where we always, when we're writing this, you can use a dot if you want to. We always go from least to greatest whenever we're writing this. It's one of the things that mathematicians like to do. So then we ask ourselves, can I make these into exponents, any of them? Well, 5 is by itself, so it's just 5 to the first power. It can't do anything. But if you notice, there's 2 of these. So it would be 2 to the second power because you're multiplying by 2 of them. So I have my standard form up here, I have my expanded form, and then I have my exponential form. Okay, now 36. 36 is one of my favorite ones because, well, I'll show you in just a second because there's a specific reason why I like it. So I like to start with 6 times 6 because a lot of you know that. If you didn't know that, that's okay. You could have done 9 times 4, 2 times 18. There's a lot of different options, which is cool. So then we know that 6 is 2 times 3. So we already know that this is here and this is here. So those are all prime. So I'm going to circle all of them. Now, I told you, make sure that when you're doing your expanded form, go ahead and write it from least to greatest, because then you can see the numbers that repeat. So if you notice, the 2's repeat twice, so that'd be 2 to the second power. This is my favorite part here. And then also the 3's repeat twice, so it'd be 3 to the second power, because there's 2 of them. That's a 2. It doesn't look like a 2, but that's a 2. So 36 has an expanded form of 2 times 2 times 3 times 3, and then it has an exponential form of 2 squared times 3 squared. And this will be our last one for today, which is 120. If you notice, it ends in a 0. So you could divide by 2, you could divide by 10, you could divide by 5. You could also divide by 3 because 1 plus 2 plus 0 equals 3, and 3 divided by 3 is 1. So we know that this divides by 3. I think the easiest one is because it ends in a 0. I know that it's 10 times this number right here, 12. And then you would just break it down. 2 times 5 gets me 10. You could do 2 times 6 to get to 12, or 3 times 4. It doesn't matter, whichever one you want to do. I'm just going to do 2 times 6 because I already said it. And then 2 times 3. If you notice, there's a lot of factors, which makes sense. Because when you divide by 0, if you noticed, we could have divided this by a lot of things. So now I'm going to rewrite. So I've got 1, 2, 3 of them. This is where a lot of people make a mistake. They forget one of their factors. And it changes the expanded form. Then there's 2 5s. So there's 1, 2, 3 2's. So the 2 is repeated 3 times. Remember, the exponent tells me how many times I repeat. Times 5, that's my base, and there's 2 of them. So it's to the second power, or squared. So 2 cubed times 5 squared. So these are both for practice. 9CP as an IXL code is just having you write it out. This one is actually having you turn it into exponents, so I really like this one a lot. Don't get stressed out by this. The more you practice, the better you get. But you're going to have to write stuff down. So please, please, please know you have to write stuff down. You can do this. You're awesome. And I believe in you. Just make sure you write stuff down. Okay. Have a great day. Oh, and one last thing. This one is going to be for a grade. The WLU is going to be for a grade. Okay, so please make sure that you look at my Canvas page to see what you need to get. Here's a hint. You need a SMART score of 70. So make sure you get to a SMART score of 70. Okay, that'll get you 100 on that one. So WLU is for a grade. This 9CP is for practice. WLU is the one that's going to be graded. You need to have a score of 70. Okay, 70 SMART points. Okay, have a great day.